In this video, we're going to go over some other examples of how to find critical points, maximums, and minimums on a given interval. So first, let's just go with the basics. How to find critical points. So for any given functions, the critical points have two different approach. First, we can find where f prime of x is equal to 0, or where f of prime of x does not exist. Okay? And the example here, we have a function f of x equals 6x cubed minus 10x to the 5 plus 5. So that's a polynomial. So the derivative is going to be another polynomial. Let's find that derivative. That's going to be 18x squared minus 50x. Notice that this is a polynomial. Hence, it's not going to have discontinuity. It's not going to have issues of the domain. And so we can disregard the case where the derivative does not exist. Now, for the case f of prime being 0, we can use some factorization here. We're going to get this factorization for the derivative. And if we're trying to find where f prime of x is equal to 0, then that is equivalent to finding where x times 18x minus 50 is equal to 0. That will mean x equals 0 or 18x equals 50. Or, to not skip the steps, where 18x minus 50 is equal to 0, or 18x is equals 50, and that will yield 50 over 18. We can simplify this. That will be 25 by 9, and that's the top that we can simplify. So this is the example of finding critical points. Now let's see another example with a proper interval. Let's take f of x equals 3x cubed times exponential 2 to the minus 2x. And we're going to take the interval minus 1, 2. Let's check for the absolute maximum and the absolute minimum. First, we find the derivative. F prime of x is just going to be a product rule here, which is 9x squared e to the minus 2x plus 3x cubed, and then the derivative of e to the minus 2x, which is e to the minus 2x, and using the chain rule, time minus 2. Now, if we simplify it a little bit, the derivative, we can factor out the exponential. And we're going to get 9x squared minus 6x cubed. And so as you can see, we can actually factor some more, and we can factor x squared from there. We get x squared e to the minus 2x, and that's going to leave multiplying by 9 minus 6x. As you can see, these are all continuous functions with our problems on the domain, so we can disregard the options of the derivative not existing. So for critical points, we're going to find out where the derivative is equal to 0. So that means x squared e to the minus 2x 9 minus 6x being equals to 0. That gives me the following options. X squared is equal to 0, or e to the minus 2x is equal to 0, or 9 minus 6x is equal to 0. Now notice this is going to give me x equals 0 on this side, and the exponential is never 0. Okay? This is never going to touch 0, so we don't get any points from here, but we get a point from 9 minus 6x equals 0. That's going to be 9 is equal to 6x, or x is equal to 9 over 6, which can be simplified to be 3 over 2. Now, that gives me all the critical points. X equals 0, and x equals 3 halves, or 1.5, any way you want to see it. Now, because we are in a closed interval and this is a continuous function, then we can apply the string theorem and just evaluate on all the points and the strings and all the points, and we're going to have our maximum and our minimum. So let's plug in -1, let's plug in 0, let's plug in 3/2, and let's plug on 2. So first is if I plug in 0, notice that that's going to be easily 0, since it's an x cubed multiplying everything else. If I plug a -1, now -1 cubed is going to be -1. So I'm going to have a -3 e to the, and so on the top, I'm going to plug the -1, and that's going to become a 2. So it becomes -3 e to the 2. If I plug in 2, now that becomes 2 to the 3 is 8. Multiplied by 3 is 24. So it's 24, but the e to the -2x can be seen as e to the 4, or divided by e to the 4. Okay? Now f of 3/2 can be seen as plugging on 1.5, right? And so that'll be 3 times 3/2 cubed e to the -2 times 3/2. So we can do a little bit of algebra in there to figure out what this number is going to be. Notice this 3 over here can be seen as 3 to the 4th over 2 to the 3, right? And this over here can be seen as e to the -3. So if I simplify a little bit more, this value is 3 to the 4 is 81 over 8, and 8 e to the 3. So now it's just a matter of computing what values are what values are going to be bigger. Clearly, the negative number is going to be our absolute minimum. And so it's just a matter of checking what's going to be the maximum. This is not going to be the maximum because they're positive numbers. And so now we have something in the scale of, well, what is bigger? 24 over e to the 4 or 81 over 8 e to the 3. So after computing, this is going to be approximately 0.50, and this is going to be, this is going to be 0.50, and this is going to be 0.43. 43.9, so almost 0.44. So in this case, the largest value is this, and this will be our absolute max.